All right, hi everybody. I'm Chris Chalfant. With me, as always, is my partner Andrew Kaczorek here. We're both from Leaf Software Solutions. Make sure I'm not standing in front of the screen here. Andrew, if you want to advance to the next. So we're from Leaf Software Solutions. We're an enterprise software development shop up in Carmel. We're in Clay Terrace in the mall. Andrew and I make up the cloud services and rapid application development team. So we do a lot of cloud consulting, migrations, optimizations of cloud environments, and also building small, short MVP software apps. And I'm going to talk about one of those today and some of the techniques we've used in serverless. So I'm going to give you a high level. I'm not going to do like deep technical demos. I'm not really going to show you code because you can find that stuff online. What we want to do is talk about why we selected this architecture, how it's constructed, and to me, most importantly, the lessons that we've learned that may not be obvious from reading blog posts and whatnot as you're learning about this way of building applications. So what do we mean by serverless? So we mean kind of two things here. Serverless is it's an architecture. It's a way of building applications and trying to avoid using running, in these days, VMs. So I don't want to patch machines. I don't want a capacity plan. I don't want to start-stop machines. I want to use cloud-native services almost exclusively and let all of the scaling, let that be the cloud provider's problem. So that's using software as a service and functions as a service. You'll hear serverless called functions as a service. But the way we talk about it also is there's a framework called serverless. So some guys real quick jumped out and grabbed serverless.com and made a framework. And usually, right, the first framework, if it's even halfway usable, is the one that wins because a community builds up around it. That's what's happened with serverless. So as soon as Amazon announced AWS Lambda, these guys jumped up, realized its potential, and started building a framework and then a company around it. So we're using their framework. So that's what I think of when I think of serverless. So who's our client? So our client is Ascend Indiana. It's a new initiative to match new Indiana grads to Indiana jobs. It's a nonprofit, and we're building the app that they're going to use to chase down good Indiana grads and find them good jobs in the state. So it's pretty exciting. It's kind of fun as folks who live here, right, to make the environment better for all of us. They're a nonprofit. So cost is definitely a concern, and ease of support is definitely a concern. So if you want to flip, Andrew, please. So why do we pick serverless for this? It's a web app. We could have used Rails. We could have used Django, Flask, you name it, whatever web app framework off the shelf that we already know how to do. So why did we take on the extra complexity? For small-scale usage, serverless applications can be more or less free to run on Amazon. You can fit within the free tier of different services, and it's almost magical. It's sort of like I'm running this web app. I got 100 or so users, and I don't pay to host it, really. For large scale, and I've got a link here to a blog post, for large scale, people have reported up to 2 orders of magnitude savings over running traditional web and application servers. You architect your app right, paying for these short by the 100 millisecond segments running these functions, and the functions are dark when they're not being used and you're not paying for them when they're not being used, can lead to 2 orders of magnitude lower hosting costs. And that doesn't even take into account the savings of maintenance, patching OSs, being paged when something gets wedged and you got to restart a bunch of web servers, that sort of thing. There's also a lot less scaling and capacity planning, which is going to be real important to our client. And odds are we're going to end up doing the maintenance on it, and we want to be able to scale that across clients too. So we want to make that easy on ourselves. So for an example, under development, we haven't gone production yet, we're running at about $85 a month in AWS. All the Lambda services and API gateway services right now for us are under the free tier. Now, granted, it's just the two of us doing development against it. And all the cost, almost all the cost, is an RDS relational database instance that we're running, which is really tiny in dev. And we're paying $30 a month for a NAT gateway because all of our Lambdas are back in a VPC, which we wouldn't have to do, and I think I'll get into that later. So what's the architecture? This is a lot of words. I'm going to show you a picture here in a second, but bear with me. So I'm going to look over your shoulder, Andrew, so I don't have to keep looking over here. So this app is a single-page app written in JavaScript. So the idea in a single-page app is you deliver the entire contents or the entire code of your application to the user's browser more or less all at once, and it runs in their browser and makes API calls to your backend directly. So to not have a web server to serve that JavaScript, we load it up into S3 as an S3 website. We configure S3 to do that, and we put CloudFront in front of it. So now we've got a CDN. We've got really low hosting costs. S3 is super cheap for storage and requests. And so we're putting the JavaScript there. For our backend, it's a REST API running on AWS Lambda and API Gateway. And as you'll see, Serverless is the framework we use to configure those resources. It's a Python backend. Serverless is sort of JavaScript first, and Lambda's kind of started with JavaScript first, and later brought Python on. So why do we have a JavaScript front end and a Python back end? We know Python better than JavaScript. So we knew we could fly right in our back end and then struggle with the front end. So that's why it's not JavaScript all the way through. If we had it to do it again with the knowledge that we know now that we're a little better at JavaScript, it might be all JavaScript just to reduce the technology footprint. But we do like the Python backend a lot. For backend workers, you can configure Lambdas to, so most of these Lambdas are triggered through requests coming in through API Gateway. But some of them are scheduled, like cron-style events. So we want emails to go out weekly or daily or what have you. Those are Lambdas. We have some media content. People can upload their pictures, and companies can upload pictures of their facilities and that sort of thing. And we filter and munge that stuff into the formats that we like, and we do that all on an event base. So as soon as that object hits S3, a Lambda fires, it runs image magic, does whatever we want to that image, throws it in another S3 bucket, and that's where it gets served up to the app. We're using, as I mentioned before, we're using Amazon RDS. It's MySQL. We're not database guys. We don't have a real hard database problem to solve, so we're sticking with RDS. It's a really small instance, and it's going to get bigger when we go production, and we'll just keep an eye on it. If we really need the performance later on, we have the option of moving to Aurora, which is Amazon's enterprise-level MySQL. We've seen other clients use it. They save a lot of money. It's highly performant. We're pretty excited about that. So I don't think in this app we're going to need it, but we got that headroom. We're using, for the Python geeks out there, we're using SQL Alchemy as our ORM layer. We're using Auth0 for authentication. So Amazon does have AWS Cognito, but it's a little bit more DIY, and we didn't want to take on that extra work, so our client's paying for Auth0 integration. We're real happy with it. Users can, go through the standard sign up, recover password, that sort of thing. They'll authenticate with a JSON web token, and then we authenticate our REST calls with that JSON web token. So Auth0 has awesome documentation. They even have sample apps. You pick what framework you're using. We're using React. We pick React, and blam, there's the code. They do a really good job of holding your hand through that process. Real happy with them. And then for monitoring, we're using CloudWatch logs and metrics. We can log directly from Python using Python's logging module, and it goes right into CloudWatch logs, and then we can build metric filters on that and alerts on that, all natively within AWS without using any other tools. So that's really nice. So here's the picture. S3 holds our static content. That's our images. That's our JavaScript SPA, single page app. The browser grabs that, and then it makes REST calls through API Gateway, which then defers that to Lambda, fires Lambdas to get the results, and then returns those results back to the web client. In this picture, which I heisted from Amazon, they're using DynamoDB as their persistent store. And we could have done the same thing and went, without RDS, but it was another technology. We know relational databases. we're a little bit scared off by how to model our data in Dynamo, and we don't really know, it's a brand new app, we don't know the access patterns that well as we're building it. So we figured later on we might replace it with Dynamo if the costs looked right and we could wrap our heads around modeling the data. In our opinion, that's kind of the tricky part with Dynamo. And we don't need the scale, so. And also, we lied, it's not entirely serverless. We have one server. We put our database in a private network, private VPC, so nobody could access it directly from the internet. And because of that, we need access to it from our workstations. So we put up a very small, what is it, a T2 micro? Oh yeah, I wrote it right there, T2 micro, for an SSH tunnel. So it's running 24/7, but it's uber cheap. And actually, I think that's free tier also. T2 micros are under the free tier for like your first year. And we've set up an SSH tunnel so that we can use, what is it, SQL Pro to hit the MySQL database and use Alembic, which is SQL Alchemy's migration tool. And so directly from our laptop, then we can run migrations against the database through this SSH tunnel. It's worked out really well. It's a little ugly to have this server just for this, and we've considered doing our migrations as Lambdas themselves. So we could deploy the code and then fire a Lambda that would then reach into the database and make the changes, but we just haven't gone to that step yet. Serverless, the framework has a plugin architecture, and I think we could do it through plugins. I just haven't looked into it yet. So we're going to get into what have we learned. And I know we're going to have plenty of time for questions. Feel free to pick our brains about this kind of stuff. We've learned a lot that we haven't put on these slides just because we had limited time. And I got some business cards if you guys want to talk offline or you want to email us or whatever. We're happy to answer questions about how this went down. So there's a lot of functions as a service frameworks that have popped up since serverless. Serverless may not be the best one for your needs. It may not even be the best one for our needs. I'm still kind of wavering on that. One that I really like that is in the Python ecosystem is Zappa. And one of the really cool things about Zappa is you can write your app in a native WSGI, which is like the standard web application sort of framework in Python. So if you have a Django or a Flask app, you can plop it right down in Zappa, deploy it out to Lambdas, and it'll work just like if it was running on an application server, which is really attractive. It's also got some things built in, which I'll get into in a second, like function warming. So we like Zappa. You have a question?
Yeah. So is the framework kind of getting rid of all the promises that you're going to have to do to like go back and forth between all these, or is that still kind of there?
So you can think of these frameworks as a way to manage your cloud resources. So to set up a serverless backend, you've got to configure lots of different services, and it's a really high learning curve to do it all manually. To wire everything together, I mean, just off the top of my head, you've got to configure like 1,000 things in API Gateway. You got to hook that up into CloudFront just right if you want to use your own host name. You got to configure host names in Route 53. You got to get the Lambdas wired up in such a way that they pass data back and forth through API Gateway in a sane way so that a programmer can think about it well. And all of these frameworks, what they should do is make you not even worry about that stuff. Just run a command line tool, and it configures that stuff for you. And as long as you sort of follow their convention, then you don't have to worry about how that's all configured. Hopefully until later when you want to do something really complicated, and then you got to understand it. But at least it can get you up and moving quickly. So in my mind, frameworks like Zappa, Amazon has one called Chalice, which is also Python oriented. Andrew's done some Hello Worlds with that, and we like it. We went with serverless because, like I say, it was the most mature one. But I could be convinced to switch over to Zappa, and I think that'd be kind of a fun weekend experiment, is to just port the whole damn thing into Zappa and just see how it goes. But yes.
Have you seen any other frameworks that aren't necessarily AWS specific that can run like on Azure or?
So serverless is trying really hard to be cloud agnostic. Then they're trying to extract it, yeah. Which, as you can imagine, is a tough problem, right? But they handle Azure and Google, and I think maybe even IBM OpenWhisk. So serverless is trying. There may be others that I don't know about.
I think there's a couple PRs
Yeah, that wouldn't surprise me. So what did we learn from the framework, from using serverless? Serverless started out with this like opinionated way to organize your code, and I kind of liked it. It was nice. It was sort of, I'm a old Rails programmer, so to be able to say Rails project new and have it all and say like I don't have to worry about how to lay my stuff out. I know if somebody follows me up, they're going to know where the files are. That's nice. With Serverless 1.0, they kind of like tried to go a little more minimal, and there's no hand-holding on like, okay, where do I put these code libraries, especially with Python, which you've got the added problem of if you've got C bindings in your Python code, you need to compile it for the Lambda environment that it's going to run in, which is a little bit tricky. The guys who do Zappa have a repo with some commonly used Python packages already compiled up for you. So that's a good way to get started. I tend to like, if I'm going to compile something, I kind of want to compile it myself. But it's tricky to get it running on Lambda. And there's size constraints too. So if you've got something that takes up a lot of space, you can quickly grow above the, 50 meg zip file that you can push up for a given Lambda code package. So there's no clear advice on how to do that. So you're kind of on your own. And we kind of did it the way it felt natural to us, but that might be tough for a maintenance programmer to follow us up and understand that. Serverless uses CloudFormation to configure all of the resources in AWS. Andrew and I are big fans of CloudFormation. We use it across all of our AWS customers. We know it, the ins and outs of it pretty well. We've even written code to drive it. But there's some limitations. So a CloudFormation stack can only have at most some number of resources, like 200 or something. And when we tried to make our whole API one serverless project, we ran out of resources. These templates got too big. And so we had to kind of adjust our thinking, and we ended up making separate serverless services for each resource in the API. And you can imagine that's kind of a headache to deal with. But we had to just to kind of get under this, resource limit in CloudFormation. That led to other problems, like we got unique host names. You got a different host name for every service. So now your API looks like 10 APIs and 20 APIs and whatever, how many resources you have in your project. And that was a really tough nut to crack. It was really ugly. I didn't like it for the longest time until I realized API Gateway has a feature called custom domain mapping, where you can make a custom host name and tell API Gateway, map calls to this host name and this part of the path to this API Gateway endpoint. So now we have one host name, and it maps to a bunch of different services. But Serverless doesn't support that, so we got to go out of bound of Serverless and manually put some stuff in there. So it's a little ugly. And that leads to my next point. There's some configuration that lies outside of Serverless. Serverless doesn't support it because, for whatever reason, Amazon doesn't have CloudFormation support for some configuration item, or Serverless just hasn't got around to instrumenting it yet. So there's some configuration that you have to do, and whether you script it through your API or you do it manually, it's just it's kind of a headache, and it would just be nice if our framework did that for us. And I mentioned that you need to compile the native code. So we'll move on. This is some lessons learned about using this in AWS specifically. So we are running our Lambdas in the VPC because they need to talk to the database in the VPC. If we were using Dynamo, we'd probably make our Lambdas public, and they would just reach into Dynamo. It's not sort of off in its own network. But because we didn't want to expose our database to the internet at large, we put it back in a VPC. A downside of that is the Lambdas take longer to fire up. The cold start time on VPC Lambdas is longer because Amazon has to provision a network interface in your VPC that those Lambdas can talk through. And if it hasn't done that yet, and your Lambdas are coming up fresh, then it's got to wait on that. And that can lead to considerable cold start times, 10, 12, 15 seconds, which is not acceptable, right, for API requests. So you got to do some tricks, and this is a trick we stole from Zappa. Zappa has it natively, but we do warming. So each of our API Lambdas, we also have a scheduled event that fires, what is it, like every 5 minutes. And each of our Lambdas has some sort of ping code in it that if it's coming from this scheduled event, it just doesn't do anything. And so we're firing every one of our API lambdas every 5 minutes to just kind of keep it on hold. It's a hack. It's kind of ugly, but we're of the opinion that possibly at the next summit or reInvent, Amazon's probably going to announce, oh, by the way, if you want your lambdas warmed, pay a little extra for them. I got to believe that that's a feature coming down the pipe. It's too obvious of a feature.
What's the performance if you had made it public? What difference? You say it's 10 to 15 seconds with the VPC.
Yeah, it's less than half that. But it's still out of the bounds of, you know, an HTTP request cycle.
It's still unacceptable.
Yeah. Yeah, you would still have warming. Just you wouldn't pay that penalty. Now, once we're in production, presumably we'll be all right until, you know, the first person in the morning hits it. But we also learned the hard way that you have to manage your database connections differently. Normally, you've got a web server that's running, you know, sort of 24/7. You want to grab a bunch of database connections, hold them open. You don't want to pay that cost to open up database connections on every request cycle. And frameworks are usually really good at managing that pool of connections. In this case, we have lambdas that come up. They may go down. They may come up and stay for a while, and they might start sucking up a bunch of connections. We might go really wide on our lambdas. We might have 100 lambdas all running at the same time. And if they're all trying to grab like 5 database connections, you could run out of database connections on your database side pretty quick. So we got really strict with that and basically tuned it down so that each lambda uses the minimal number of database connections, and we give them back right away. And even on the database side, we've set really tight, really short expiration times on outstanding database connections for that purpose. So we're going to pay a little bit of time when the thing warms up, but in the grand scheme of things, it's better than trying to really closely manage this resource pool. I mentioned the custom domain path mappings. That was a really, really big learning for us because we wanted one host name for our API. Oh, and then one that really kind of bit us was CloudWatch logs are not set to expire by default. So you get a whole bunch of lambdas going, and you're getting really, like, we go nuts on debug statements, and our logs get really big. And then we realize, wow, these CloudWatch logs are way too big. So we wrote a lambda that will periodically look at any new CloudWatch logs and set their expiration to like a week or 3 days or whatever the heck it is. Because you can make new lambdas and forget to go set the expiration, so we just have a lambda that does it for us now. I'm going to start speeding up because I'm running out of time here. CI/CD. So how do you do your build workflow in this environment? This turns out to be really cool and very elegant. And if you got any questions, Andrew built it, and he's happy to answer those questions. We're an Atlassian shop, so we use Bitbucket for our code repository. Bitbucket has a beta service called Bitbucket Pipelines, wherein they will launch Docker containers to run builds for you on commits. So on commit to master, we launch one of these Docker containers, and you just put a YAML configuration file in your project, and you can give it shell script commands that'll run on the build. So that's how you can build and test. It works really well. We love it. We're not running any build servers at all. You just pay more or less by the minute. And we ran out of minutes here a while ago, right? And we had to buy some more. Yeah. So your capacity planning is not like, oh, I need to run another build server. It's like, well, how many minutes are we going to build this week? I don't know. But that's really nice, you know. So when we go home at night and we're not running builds, we're not paying for anything. We probably should run our database migrations this way too. We're still a little scared to have automatic database migrations, but honestly, we could code that up as a Lambda and have that run as part of the build, and we should. Our builds both deploy the API backend with serverless, but they also deploy the web front end to S3. So you've got to push the files to S3, and you've got to poke CloudFront to update its cache to, what's it called, invalidate the cache. So we do that too. It works great. We don't even think about it. I mean, it didn't take that long to set up, and we don't even think about it. The stuff where we learned the most is learning how to build a single-page app with JavaScript. Neither one of us are JavaScript developers. We're back-end guys. And man, it's hard to wrap your head around that. The learning curve for JavaScript, we picked React because we figured there was going to be a nice community around it, having come from Facebook. And we like the idea. React has this notion of reusable components, or at least that's what it's touted for. And that's really worked well for us. So we can build one UI component and reuse it throughout the app with some parameterization. And I would say that that's been a really steep learning curve for us. Like, we feel like we can learn stuff fast, and then it's sort of like, oh my gosh, this is really hard. There's a lot of blog posts out there, but it's like I say, welcome to JavaScript. I mean, I'm sorry if I'm going to offend anybody that likes JavaScript, but that ecosystem is jacked. You know, like, things bubble up, and this is like, oh, you should use this right now. And then 6 months later, it's abandonware. And you find this old blog post and go, oh, this is cool. This solves my problem. But, oh, nobody uses that anymore. We use skateboard.js or whatever the heck, you know. So that's really hard to deal with. And then along with that rapid change comes dependency hell with the different modules. So you want to upgrade this thing, and that causes a cascade of these 100 things need to be, literally 100 things need to be upgraded. And does that break something in your app? So we peg versions on everything. That's an old practice that we learned ages ago. We peg versions on all these modules, and we do not take upgrading one lightly. Like, it's not, oh, I'll just upgrade this as part of this user story. It's like, no, wait, are you serious? Do you really need to upgrade this? Because that could break everything. So I recommend using a starter kit. There's even more. I went and looked today. There's even more than when we started this, like, what, 3 or 4 months ago. Facebook's got, like, create a React app, which is really nice. Then people have built on top of that. They're sort of like starting to be a standard toolkit around React apps. And so I highly recommend taking one of these starter kits and letting them decide how you lay out your directory structure, where you put your code. It's a lot easier to understand that way. I would also really recommend doing several hello worlds with React before you decide to write production code in it. There's one that I linked to in here that is invaluable to us. It's a company up in Chicago. A developer up there wrote this amazing tutorial. It's like a blog post in 3 sections. It's really long, but it's really nice. It really helped us. If I could meet her, I'd shake her hand, because I was like, man, you saved us a lot of time. The big thing that we wave our hands about is, what about search engine optimization? This whole app is one big JavaScript program, and I have no idea what Google's going to do with that. There's a lot of talk about how to solve this would be to go back and just have the Lambdas generate straight HTML and hand that back to the caller, instead of, you know, pushing the whole JavaScript app down to the browser. That's not a problem for our client right now, so we're sort of like, okay, we'll deal with that when that becomes a problem. But that's definitely something. There's, I don't have this in the notes, but Andrew, you were telling me, there's a company in South Bend called Trek 10. They're big contributors to Serverless. They've got a guy there named Jared Short who's really sharp, and he's a tech evangelist for this kind of technology. He's got some good talks from Serverless Conf. Yeah, there's a conference for Serverless now. And I recommend reading those to kind of see where things are headed in that space. Okay, so that wraps up kind of our lessons learned. We wanted to mention that if anybody here is going to the AWS Summit next week, right? We're going, and we'd love to have beers with people, because we like beers and we like meeting geeks that love AWS. So we put our emails up there if you want to get a hold of us. And also, the obligatory slide, we're hiring. We're looking for an open source developer who can also help us with the cloud services. So if you've got those skills, or you know somebody that does that's looking for work, send me a resume. We're happy to talk to them. I assume this deck's probably going to get posted somewhere, so I put some links up here. Some of these links I mentioned, some I didn't. These are things that we really found useful. Maybe you can cut through the noise and find some good things. That React tutorial's in here. Some new stuff popped up from AWS. There's like how to make a serverless app. Just popped up on AWS like a week ago. And then there's another one that I haven't even had a chance to read through yet, which is sort of like how to make a Hello World serverless app in this ecosystem. And I've got that link too. That's the serverless stack. That's really nice. There's a book. It's a good book. And then I put one of the starter kits up there too. So that's all the slides we have. I know we have about 10 minutes for questions. We're both happy to take questions. Oh, yeah, I got to push our meetup. So we have Leaf hosts an IndyAWS meetup every month. It's typically the third Monday of every month. You can also find us on meetup.com. I saw some hands go up. Steve?
With the stuff that lies outside of serverless and these other custom things you have to do, do you really think you're getting a lot out of using the framework, or would it be easier at this point to not use it and just push, like, manage the Swagger files for the API?
Yeah, that's a great question. It's a lot of stuff. I would say of the stuff, and I'm completely spitballing here, of the stuff that you have to manage outside of serverless, it's maybe 10%, 5%, something like that. So it's annoying that you have to do the extra stuff, but it's not enough for me to go, all right, because we also thought about writing our own framework too, but then if we're doing that, our client's paying us to write a framework and not their app. So so that's kind of out of the question. But I get to that. I'm like, if they only had this philosophy, it would be so much easier. Yeah, honestly, we could get a little bit better. We've recently started playing with Troposphere? No. Terraform. And yeah, you've heard us talk about that at the DevOps meetup. So you could do some of that stuff probably with Terraform, since it's not using CloudFormation, it's direct AWS calls. We could make that problem go away if we spent like a day on it.
I had a question about deploying the API.
Mm-hmm.
So you said that you run CI and pipelines. I use pipelines as well. It's great. So how does the deployment happen after all your tests have passed? And you set up is there a webhook or something?
So what we do is we put some AWS keys that all they can do is kind of deploy the code as environment variables in pipelines. And then pipelines just walks through this list of services we have. And there's a command in serverless called deploy. So we say serverless deploy this thing, serverless deploy this thing.
You just throw in the credentials and it knows what to do.
Yep. It does all the work for us. Way in the back.
Why is it, and it kind of struck me, I know you guys are in dev, why is it that your RDS is it $50 a month? Or
Yeah, we're multi-availability zone for redundancy, which we don't really need in dev, but we are because we're AWS guys.
that because of the trying to put together stuff you thought you might need?
Yeah. And this is a relatively new client, and there's some, I'm looking for a term for it. There's you want to put your arm around a hosting budget, even if it's more, because you want to give them the impression okay, this is what you should expect to run this thing. Because what I don't like to do is come back and say, oh, it's going to be 2x that or 3x that. So we tend to go a little generous in the beginning to get them used to that bill, and then we'll come back and ratchet it back to the appropriate size. So there's some of that going on there too.
Could you go into a little more detail about how when you split essentially what was a monolith into more of a microservices sort of architecture, what does that actually look like on your local PC? Do you have separate folders for every part of that?
Oh, yeah, that's a great question. So if you start out with serverless and you just say serverless new, it makes a new service. And that can comprise multiple AWS Lambda functions. It can have one or more of those. And their notion is that a service is sort of they liken it to a resource in a RESTful API. So you make one service, and then you have, 4 or more Lambdas for CRUD, create, read, update, delete. So what we've tried to do is, our project is, we started with that, and we had one big thing, and we just kept adding functions to this thing, and it, like I said, it just grew out of control. So the way we set it up is, we have, a directory for scripts that we run and build and that sort of thing. We have a directory for our library code. So this is all the Python modules that we wrote that encapsulate the business logic. And we have a directory for tests. We use Mamba. So I have a spec directory for all the spec tests. And then there's a directory called services. And then within that, there's a subdirectory usually for every HTTP resource. So like we have job seekers, so there's a seekers directory, and we have recruiters, there's a recruiters directory. And then in that is a separate serverless project. So each one of those has one serverless YAML file, which is their config file. And those are the ones that we have to walk through to deploy. So we go through that list of CD into this directory and deploy that thing, CD into this one, deploy that thing, and then kind of go through there. Does that help answer your question? Oh, and then we symlink that library into each one so that on deploy, they each get a copy in their zip file.
So basically you go in there and then you just commit it and then that goes straight to the pipeline, into your pipeline?
Yeah, and it's all one big repo. So when we make a commit to that repo, it goes off and runs the tests, and then if they pass, it deploys everything, even if that thing didn't change.
In a much more larger project and larger team, you would probably split everything into their own repos so that just changing one particular resource would only trigger tests and builds and deploys of that resource. And people could change that one thing independently. But that sounds like work because we didn't deal with 15 or 20 repos.
Right
Right now, man.
And we have the luxury, it's just the two of us working on the code base, so you can get away with being a little more sloppy in your communication.
Is it just you have the development environment and then production, or is there a test that is separate from dev?
We have a dev environment and a demo environment, which we use for user acceptance testing, more or less. We haven't even built the production environment yet. We're moving up to like a mid-August release. So we're going to build the production probably next week.
So you just specify an environment in the serverless fan?
Yeah, there's a -- stage, and you say what stage you want to deploy to.
Chunk in that YAML file for Bitbucket pipelines also, where you could have each one be separate steps for the different stages.
Any more questions? Sir?
Building out pretty much exactly the same thing as you are. I'm also a Python backend developer normally. Would you say this was like including the learning curve of all of your AWS business? What was this like timeline-wise? If it normally takes you, say, 3 weeks to build this API, what would it take to get it all serverless from scratch?
Yeah, that's a great question. I'm gonna set aside the JavaScript stuff because that's a whole different thing. I would say that I did not have the benefit of, say, something like Flask, where you can easily set routes and kind of reason about it well. So I had to kind of come up with my own way to do it. And so I would say that maybe added, I don't know, over the whole course. We started this in April, I think. Over the course of that, it might have added like a week or so total, maybe. I don't know. Because I'm working on it piece by piece. Like if a piece annoys me enough, I'll go in and refactor it and make it, make more sense. One of the things that we didn't have, but I don't think I would have had it in Flask, was notion of role-based access to resources. So we have one API, and we're using that for like admin level stuff and user level stuff. And so I need to take a look at my JSON web token, see what it says the role is, and the API then will, restrict the stuff that it returns based on your role, say the user's role. And I kind of built my own thing to do that, which I think I would have had to do anyways. I couldn't really find anything out there that did that.
Other than having a separate API for the...
Yeah, I thought about that. Have a separate admin API from the users. We'll probably get there at some point. That helps with security, I guess. I'm trying to think of some other stuff that we maybe... The learning, because the serverless framework does a lot of the work for you, you move pretty quick, And so you quickly get to writing business code, not mucking about with lambdas.
What was the reason, maybe you said it and I just missed it, what was the reason you decided to go JavaScript front end, Python back end versus just Python all the way through? Because I thought one of the primary languages of Lambda was Python.
It is, yeah. The first language they came out with was JavaScript. They quickly added Python in there too. We're back-end guys by training, so we knew Python already, and we're really good at writing back-end server code. So that sort of wasn't a concern for us. We knew that we could hit the ground running on that. This client in particular has very high standards. They worked with a design firm, and they mocked up all the screens of the app before we were even engaged. So we have to make everything look just right for them. with JavaScript. So that's where our learning curve was. We needed the interactivity of like a rich front end app, and we thought, well, we can do the traditional way with like something like, I don't know, Django, or even we could have done Rails as well, and then sprinkled the JavaScript in on the front end to make it look nice. But we thought, let's go all the way. We'd been doing some work on single page apps, kind of dipping our toes in it. We said, let's go all the way with that so that all our front end code is kind of like in one place. It's easy to reason about. It's componentized. So I bagged on JavaScript a lot, but there's a lot we gain from it too, like this reuse of code. We gain a lot there. And to be honest, I would consider going all JavaScript on the next app. I would consider it. You know, I'm not entirely sold on it yet because I'm really good at Python versus JavaScript. But it would be nice to have just one language all the way through. I hope that answers your question. Any other questions? No? Well, thanks for letting us come and speak. We appreciate it. Thanks.